and this is the domain size I'm going to take it. So this is the point I am taking, center point 0, 0 point. It is at 25% of the card. From there, I am drawing one semicircle. After that, I have one rectangle. Then I am splitting that single face into 5 different faces. 1, 2, 3, 4, 5 faces I am splitting. Initially, there will be only one face. Then I am splitting that into 5 faces so that I can define the mesh in this region and all. So that I can create refined mesh over the airfoil. And the domain size, vertically I am taking. So for example, if this is 100 mm, then the vertical distance I am taking 15 times. 15 times the card I am taking. And this horizontal distance I am taking 25 times the card. Mostly we will change it from 20 to 25% of the card. Is it clear? Sorry, times the card. So
sir,
domain
which one is 100 mm, sir? The card?
Card is 100 mm. Here I mentioned card is 100 mm, and this vertical height is 15 times the card. This horizontal distance is 25 times the card. That much distance I have given so that there is no flow disturbance. If the model and wall is very close to each other, then there will be a boundary layer growth from the wall and there will be interaction. So you cannot simulate flow over the airfoil properly. So we have to give enough distance, both in vertical and horizontal distance. So this minimum we have to fix 10 and maximum 15 you can try. You can go beyond 15 also. And here also minimum you take 20 to 25. If you want to extend, you can extend further 25 also, it's up to you. Okay, so here I have taken 15 and 25. Is it clear?
Yes, sir.
And the blue color, the arrow mark shows the refinement. So here I am going to give number of divisions. So in the previous experiment, simply we divided into equal number of divisions, right? For example, if you give 5 divisions, it will divide equally. But here I am going to use bias. Another one option in the division. Bias means, so we have to give another one bias factor value. For example, if I give bias factor 20, then that means it will create the mesh like this. That is fine here, then it will increase and coarse here. So 20 means the last cell size, for example, this is X, last cell size divided by the first cell size. So that means this is 20 mm, for example, this is 1 mm, then the factor is 20. So it is a ratio of last cell size to the first cell size, bias factor. So this option we are going to use it. Using that, instead of equal distance divisions, we are going to refine the mesh near the airfoil. So all that blue color arrow mark shows refinement towards the airfoil. Okay, all these vertical lines it refined towards the airfoil. This horizontal line also it is refined towards this airfoil. Only here, yeah, here also it is refined towards the airfoil. So you will see how it generates. Is it clear?
Yes, sir.
Yes, sir.
So while you create that domain mesh also, you can use this as a reference. What is the size you have to take it? So some people may take 5%. There they will draw the semicircle and proceed. Here I have taken 25. Some people will draw from the leading edge itself. It depends. It will vary. Okay, the number of blocking, the way of blocking and all, it will vary. So mostly they will prefer this 25%. So I have taken this one. So the first step, so creating the airfoil profile, you know how to do that. Then second step, I'm going to create the domain. Then I'm going to fill it using wireframe and surface design. Then third step, so in this sheet, I'm going to remove this region because already I have the airfoil profile. Using split option, again this is also in wireframe and surface design. Then I'm going to make further cuts. That is, I am dividing the single sheet into number of blocks. So here I made 6, but I'm going to try with the 5. For example, here I made 6 blocks like this. Then you can go for the mesh. Initially, if you import, you'll get unstructured. Then using face meshing, you can get the structured. Then we can do the further refinement towards the airfoil. That's what we're going to see here. So we will start with the downloading the coordinate points, then importing, creating, etc. and all. Any doubt in this?
No, sir.
Yes, sir.
Okay. So at last, this page, I will tell you, we're creating the mesh. This is the online calculator. This is to find the first cell height. As I mentioned, if you are simulating flow over the airfoil, then there will be a boundary layer. For example, assume this is the boundary layer, and we are going to create the mesh over this, and at least 10 to 15 lines should fall below this boundary layer. Otherwise, we cannot predict the flow of the airfoil properly. Okay, simply if you give 10 mm, then the first cell height may be above the boundary layer. So we cannot predict what happens inside the boundary layer. So we have to find what should be the proper first layer cell. For that, we are using this online calculator. A number of calculators are there. Simply I have taken the first option point wise. This was first I got it in the Google. So for example, I am taking 20 meter per second. I know the standard atmospheric conditions, density, mu value, and I am taking chord is 1 meter in the setup. So the reference length is 1. And for the proper prediction of boundary layer properties, the y plus value should be less than 1. So at least I am taking 1. So with that I got the first cell height should be 0.0000 approximately 2 meter. This should be my first cell height. So this you have to check it if you are going for the airfoil simulation. So you know from where to get the coordinate points, right? Which website?
UIUC, Airfoil device.
Airfoil tools you can try. Otherwise,
UIUC Airfoil device.
what is another option?
UIUC.
Airfoil tools are UIUC.
Airfoil device.
So you can try UIUC airfoil database. So I'm going to take again the normal model NACA 2412. So I'm going to click this N. So here to find that you can use the search option NACA 2412. So here I have that file. Open that. So this is the first step. Okay. So first get the file. This you can save it as a document or simply you just keep it, no issues. The next step. What is the next step?
Going into the Excel
to
sheet.
Excel file.
So take the data and
Where is the
copy it in the notepad or something.
No, sir. Go to
It's okay.
So go to
the document.
computer.
Okay. Go to my computer. Then program files. Then
Dassault system.
Dassault system.
then Intel, then
Code.
Code, sir.
code, then
Command.
command, then file name.
Find
The GSDs,
Good.
point splines.
GST first.
Type GSD. It will show the options. We have 3 files. Which one you
Point
have to type?
spline log form Excel.
Yeah. So GSD underscore point spline log from Excel. So this file you have to copy. Okay, you should not cut it. You have to do the copy. Then paste it in the desktop. Then open the file. The next step.
Remove the middle part and just
Okay, so remove the middle parts.
import the coordinates there. Copy the
Okay, import
coordinates.
the copy paste. Before that, I'm replacing this somewhere here. Where is the file? Okay. Now we can copy these coordinates.
Copy the coordinates.
Okay, I'm pasting here. Then
Data,
go to data,
text
The
column,
first,
X2 column,
the
text with
text
first and
with
last should be
next.
zero, no sir.
Yeah, that
Z
you can
coordinate
change
should
it
be.
next.
and
Now
after that
both the thing in single
coordinate.
column. What he is explaining is splitting into two columns. So use X2 column, use fixed width, and simply next. Now I got two columns. Now you can change it this to 0.
No.
Now make this as 0. Then
So
Third,
third coordinates will be
Z,
0.
Z axis also.
third coordinate should be 0. Then
Paste that end curve and
okay, this one cut and paste.
run macros.
And macros, where is it?
There's a view.
View, sir. View.
The view.
Macros.
Okay, select macros then.
Sir, fuel main.
Main, sir.
Fuel main.
Here. Here.
Sir, there's
Open all.
Uh,
This was
this was
This workbook.
main,
main.
Main.
run,
Then
Done.
run.
run, sir.
3, sir.
Then 3 after that.
3, then okay.
And okay. What will happen if you give okay?
It
Sir.
will the aerofoil will come in CATIA, sir.
CATIA, where is the CATIA?
Sir, we didn't open
So
CATIA.
we need to open first, sir. We need to open first.
So first we have to open the CATIA. Always after will confuse where to import it.
Yes.
So open the CATIA. It will take time because of these two software here my system is hanging. If you are trying in your personal laptop, once it is opened, it may take time. So don't open it again and again. You can go to the task manager and check whether you selected or not the software. So it is already loading. Okay. It seems you didn't click it properly. Okay, you should not open again and again. Check the task manager. Already I clicked, so it will open soon. So before importing, CATIA should be opened. So everybody remember all the steps. Then I should have skipped it. I wasted 15 minutes, I think. Okay. Sorry. So what's the next step now?
Part design.
Sorry.
You have to go to part design and then run macros.
Yeah. So the default window will be the product window. So close this. Then where to go?
Start
Start.
mechanical design.
Design.
Part design.
Part design. Good. So the default window, product window, that you have to close it. Then open the part window. Okay. Now you can import the coordinates. Everything here it is set. Macros. This workbook main run 3. Then enter. Okay. So it is importing the points. Now next step.
Sir, so we need to project the airfoil that we have imported and delete the imported
Okay.
ones.
So first I can select this fit all in so I can see the points lines clearly. Next step, how to project it?
Select a plane.
Create a
Plane, which plane?
So the plane in which
Okay. The plane which is parallel to the
XY
profile,
plane. Yes.
XY plane. Then go to
Go to
sketch.
sketch.
Then
So
project.
select the curve, like select the points or
how,
imported points.
how
Sir, box select, sir.
box selection, why box selection? Okay, after box selection,
Sir, we can go to the last option in operation toolbar.
so you have to do the box selection. All the points line, everything is selected. Next,
Sir, only the curve we need, sir. Of the,
yeah, we need only the curve. We don't want these points.
yes, sir.
So curve is selected.
Then the last option in operation toolbar.
What is it?
3D project? No, sir.
Project
3D.
project 3D element. So select the curve. Then in operation toolbar, so project 3D element. Next, it is projected.
Sir, we need to provide the,
Simply we have to go back.
yes, sir.
Say okay.
Exit and delete the curve.
Go back then.
Delete the Excel curve.
Sir, actually we need,
Hmm.
no. Sir, after projecting, we need to select the projected one and copy it.
Hmm. First project it.
Then copy it.
Then you have to copy the projected one.
Then go back.
Yeah, then go back.
Delete
Then
the
you
geometry.
import this imported points, etc. and all, delete it.
Then again select the XY curve and
Select the same plane and go to the sketch because we copied from the sketch. Now you can do Control V. It is pasted. Okay, next step.
now scaling, sir. The chord length we need to scale.
Okay, where is the tool? Scale tool.
So it's in
Sir,
the mirror sub option.
Okay,
yes, sir.
expand this mirror.
Yes, sir. Scale
Which
option
tools?
is there. There will be
First,
scale one option.
okay,
Yes, sir.
this is the scale. So the line is already selected. Next step.
So
Select the
duplicate
point.
mode, strike off the duplicate mode.
No, so first time we have to try with the duplicate mode. Otherwise it won't be created.
Okay, sir. Sir, we need to select the the origin
Select the
point.
point's origin.
Okay. So reference point I have chosen then.
Then in value we need to put 100.
Okay. I need 100 mm. So give 100. Next up.
Sir, we can delete the
Small one.
the small one.
The projected one we can delete.
Now zoom
And now
out.
we can try fit all in. Now this is our final airfoil model. Okay. So first I created the airfoil model for 100 mm. This is the first step. Now I'm going to create the domain. So start mechanical design, part design. The same thing it comes. But I save this once. So open the new path. Take the same X-ray plane. And then create the domain like this. First one semicircle. The radius of 15 times the card, that means 1500. It all in. Then using this profile toolbar. First tool is profile. I can draw the remaining rectangular closure. So it should be in a green color line. Only this is in white color. Now where to give the dimension to convert this into green?
Distance from vertical axis.
Distance from vertical axis to this line.
Yes, sir. Yes.
Good. So this is 2500. Good. Okay. The outer profile is created. Next step, I have to create the surface on it. Where to go?
Sir, start mechanical design,
Start mechanical design.
then wireframe and surface design.
Wireframe and surface design. Where is
So
the
now
fill tool?
sir, a multi-section surface. We can give fill tool. Yes, sir. Fill tool.
Yeah. So in the surfaces toolbar, the third one from the last is fill tool. Simply select it. Now it is filled. So this is the first step. Okay. So I created the domain. Next step, I'm going to place the airfoil here. Then I'm going to remove the material within the airfoil. So again, select this face or this plane. Anywhere you can create the profile. It's up to you, face or profile. That is plane. I'm selecting the face. Then go to sketch. So here I'm going to paste the created airfoil profile. Copy the airfoil from here. Minimize. Go to this page. Paste it. So here I pasted. But I said the 0 point I placed it at 25%. How to move the airfoil?
So we can translate, sir.
Where is the translate? Operation. Is the translate right?
Yes, sir. So minus 25.
What is the next step?
Strike off the duplicate one and then
I got the duplicate mode. Then,
so select the origin point.
okay. So on reference point.
Move towards left.
So I'm
Yes.
fixing the distance 25 mm. Then it can be moved to any direction. I want to move it here. Now this is fixed. Okay. For 25%, I'm keeping
Yes,
the 0
sir.
point. The next step, exit. Now I have to remove the material in this portion because wherever the fluid flow goes, only in that region should be covered with the face. Other faces should be removed. So next step, I want to remove this face within the airfoil. What is the next step? So this is a surface. So it should be in wireframe and surface design. In the operation, second tool is split. Using that only you are going to split it. So element to cut is this face. Okay, this face only I am going to cut it. And cutting element is the airfoil. So my cutting element is this airfoil. Now see, the color changed. Okay, and simply give OK. It is removed. Okay, so element to cut is the face. Cutting tool or element is the profile. Then simply give OK. It will remove the material in that. Is that clear?
Yes.
Yes, sir.
Okay, next step, I'm going to create the blocking. So like that I'm going to make it. So to create that, so first I'm going to create one rectangular box here. So this rectangular box has a cutting element. So my face will be divided into 1 and 2. Next, I'm going to draw another one rectangular box here. Now these two will be further divided. This may be 3. Then I'm going to draw one line here. This line will split this into 2. So 4, this 5, like that I'm going to divide it. Okay, so to make this 5 division, first one rectangle, then second another one rectangle, then one line. Using that I'm going to split it. Let's see how it comes. Anyway, you can try it here actually. So again, to draw the profile, you have to go to the sketch. The sketch can be drawn on this face or this plane. So I'm drawing on rectangular profile. So if you want, you can coincide these two lines, etc. and all, or if it is coming out also, no issues. But here it should be proper. This line should touch the trailing edge. Okay. So for that, you can coincide this line and this point one way. Otherwise, you can give distance between this line and this axis. What is the distance?
75.
75. Okay. Then exit. Use the same split tool. This is my cutting element. Sorry, this is my element to cut, and this is my cutting element. Initially, if you select, it keeps only this face. This will be removed. That's why it is in transparent color. But we need both faces, so you have to select keep both sides. Then OK. Okay. Now this is separate. This is separate. Then the airfoil at 25%, I'm going to split it. So I'm going to draw another one rectangular profile. So select this face. Go to the sketch. Draw one rectangle. Simply draw it like this. And now this line should be at the 25% of the airfoil. That means with this axis. So you can coincide these two lines, or you can give 0 distance between that. It's up to you. So this is my second cutting profile. Exit. After exiting, this will be selected. It will be in orange color. You have to select outside so that all the lines should be in white color. Then you can go for the split option. So this is my element to cut. You should not select this face. Okay. So this face I'm going to split into 2. So select this face as the element to cut, and this line as the cutting element. It's asking there is one small region inside it. Yeah, we are aware of it. And here I have to keep both sides. Then select. Then keep all sub elements. Now it is divided into 1, 2, 3, 4. Okay. So airfoil is already here. It is opened. So with a single click, I divided this into 2 separate faces. So 4 faces I created. Then here also I would separate it. So select the face, go to sketch. Again, you can draw a rectangle, or with a simple line itself, you can split it. And that line should coincide with the x-axis. The line can originate from any distance, no issues. Then exit. And again, go to the split tool. Now this face is the element to cut. And this line is the cutting element. So it divided, and this is going to be removed. But I need both faces. So keep both sides. Now it is divided into 5 regions. 1, 2, 3, 4, 5. Is there any doubt in this?
No, sir.
Okay. So you no need to worry about these extra projected lines. If you want this also, you can bring it perfectly with the coincidence. But if you go to the FLUENT, these extra lines will not be visible. Only this face will be visible. So we no need to worry about this. That's it. So the facing is created. You save this as both CATIA file and IGS file. So okay, domain. So always save it as CAT part and IGS so that the CAT part can be edited later. That's it. This step is over. Now you can go to the meshing part. Shall I close this or should I repeat any steps here?
No, sir.
No, sir.
Okay. And now you can go to the workbench. Hi, sir. Anything to add, sir?
No, sir. Fine, fine.
I thought why everybody is speaking with a low voice, but I only didn't increase the volume. Okay, so in the workbench, open the FLUENT. Then you have to import the geometry in the IGS file format. Right click, import geometry, browse. Just now we created. It is in the desktop, domain.igs. So after this tick mark, you can go to the mesh, right click. It's opening. See the blocking, n number of ways are there. So here I had 6. Now I explained it only 5. It's up to you. If you want, you can further divide also. Okay. If you want, you can further divide here. Some people will create the domain like this. Inclined lines. So n number of ways are there. So this one I just tried. It worked, so I am explaining to you. This is what I explained. If you want, you can give another one division here, or instead of the straight line, you can go for the inclined lines. Here also, you can go for the inclined lines. It's up to you. Any type of domain you can create it. Okay, 10. See, there is no that outer lines and all. Only the face will be visible with the 5 separate faces. So here, what is the next step? Imported. Then
Naming.
yeah, first you can do the naming. So again, this is 2D. So we have to name the edges. So you have to go for this edge option. So we have to select where is the inlet, where is the airfoil, where is the outlet. So this is my outlet, these 2 lines. Press Control and select both lines. Now right click, create named selection. This is the outlet. And I'm going to take the complete thing as the inlet. Some people will define this as inlet, this is wall. Okay, so if you are going to take this as wall, then you cannot go for this inclined injection because here you define the wall. If you are defining the flow in this direction, then from the wall there will be a disturbance. Okay, so if you are going to keep only one domain, and simply for changing angle of attack, if you are going to change the velocity component, better make the complete line as the inlet. I'm going to select all the lines. I'm going to name it as inlet. Now right click on that lines. This is my inlet. Okay, so this is outlet. The complete line is the inlet. Then we have to name to the aerofoil. Again, edges. Press Control and click markings. What happened? Where is that? Not selecting. Sorry, okay. So after me, I know the airfoil has to be given. It is not letting me to select it. So, okay, I will give it a little later. So
Sir?
after giving all the names, you have to select this generate.
What is the issue,
Yeah,
sir?
it's okay. Let me try this. So you have to give Sir, Ravi sir. Hello.
Yes, sir. Yes, sir. Yes, sir. Tell me, sir.
Just I couldn't give the select the edges for the airfoil. So let me generate. Then I can give the name. There won't be any issue.
Okay.
So once it is imported, first you generate. So the software will generate a default mesh. So this is a default mesh. This is unstructured. This contain both quadrilateral and triangular. Then also you can give naming. Sir, it is not letting me to select the edges. Why? Did I select anything? Why, sir?
It should be able to select with the, but you have, when you select the edges, I think it should be done. But it's already selecting with the edges for me, right?
And nothing got selected. Even I couldn't select the face, line, anything. Something happened. Or it is hanging. Okay, now it's coming.
What did you do?
Now this won't happen. First time I'm experiencing this issue. I don't know, something automatically it is coming. So this one we have to name it as airfoil. Select R4 lines. Then right click. So I created the names. So this is the airfoil. And this is the inlet. This is the outlet. And after generating, I'm getting the unstructured mesh. Now how to convert this into a structured mesh? Hello?
Sir, mesh options.
Mesh options.
Face meshing.
Which one?
Face meshing.
Yeah, face meshing. Yeah, correct. So you have to select the faces, press Control, and select all the 5 faces. Then apply. So everything should be a quadrilateral. Then update. Okay, now there is no triangular meshes. Everywhere it is rectangular. Now we can refine the edges, all the edges separately. So let's start with the airfoil. In the airfoil, So this is 25%, this is 75%. And we know most of the flow changes occur in the leading edge portion. So I'm going to create a very fine meshes in the leading edge. Then after that, some little bit coarse, medium or coarse meshes in the trailing edge portion. How they will create means some people will refine both inlet and the leading edge and trailing edge. Some people will refine only the leading edge and they will give some medium relaxation to the trailing edge portion. So here also I'm going to try only the leading edge portion. When you try, you can give refinement to the trailing edge also. It's just for the demo purpose. So simply if I increase the number of divisions, it will take more time. So to give the refinement, again go to the mesh, insert, sizing. So we have to select the size, that is edge. So select the edge tool, and these two things I'm selecting, two edges, and apply. Okay, these two edges are selected. I can give element size or number of divisions. Better I go for number of divisions. Here I'm giving 100. And this behavior, soft or hard. So mostly for the airfoil, better you go for the hard. Hard means it will try to create the proper coverage with this airfoil. The soft sometimes will not create the proper mesh cells. Okay, so better to create the proper mesh, you can give the hard. So it will force the software to create the mesh cells to cover the faces. So initially, if you give 100 divisions, it will divide that into the equal number of divisions. But I need refinement in the leading edge portion. So I'm going to use this bias. Now it is no bias. Now I'm going to give the bias. Then we have to give the bias factor. So I'm giving 20 as a bias factor. That means last cell to first cell ratio. Now see, after giving this 20 and select somewhere, you can see the refinement. But this line, it is coming differently. So what you have to do, at a time we can do the refinement for only one line. Okay, so this line selected minus, that is remove this line. I'm going to give bias for this only the bottom curve, 120. You can update or you can do for the next one also and update later. So okay, you can update it, no issues. In the bottom, you can see 5% meshing. So we are given to only one side, so it couldn't create the structure. So software is disabling this face meshing and it is generating unstructured mesh. But you can see it is refined here. Now I'm going to give the upper surface also. Again, same mesh, insert, sizing. Now you have to select the upper edge, apply, number of divisions, 100. Here also I'm giving hard only for the airfoil, and bias. Last time for the bottom I selected the first one, so this time I'm going to select the second option, and bias factor is 20. Now you see it is refined here. This one you can see trial and error. For example, if you are selecting the first one, it is showing the reverse manner. Here it is coarse, here it is fine. So you can change it to second one. Now it is refined. Okay, now again you update it. Now see it is structured. Okay, in the frontal region it is structured. Very refined as measures in the nose region. Is that clear? The same step we are going to proceed for all the edges. So it will be easy only. Now I'm going to keep this outer semicircle. Again, you have to go to the mesh, insert, sizing. Now you have to select this edge, apply, and number of divisions. What is the number of division here? Any guess? So the software is trying to create matching with this profile and this outer profile. The airfoil leading edge profile and this outer profile. It will try to create create the matching. Now what should be the number of divisions? Are you there?
Yes, sir.
100.
100.
Sir, I think
I
as
have
per the
given
factor,
here
200.
100, here 100.
200.
Yeah, it should be 200 because I selected the complete semicircle. So it should be 200. And bias factor in the PPT explained, I'm going to refine in the edges because airfoil is here. That means the third option, right? The third option, if you see outer, it is very small. Here in the center, it is coarse. So select the third option. Again, bias factor, it's up to you. Now I'm going to check with the 20 itself. Update. It creates like this. Okay. So it creates the refined area for the aerofoil. And you may ask, sir, how you are giving this 100, 200, 20 and all. Everything is simply a trial and error method. So you have to do the mesh study, mesh independence study. So you have to prepare the chart. So first, for example, I'm taking 100 divisions here, and I'm going to try 70 divisions in the trailing edge. And y plus value, that is first cell height also I am going to vary. So for this, I will do the analysis. I will check CLCD value. And we know the experimental value of CLCD for this NACA 2412, you can get it from the internet. You have to compare with that. If it is matching, so okay, then you have to further refine it. Next time, instead of 100, I can take 150 or 200. Here, instead of 70, I can take 100 or 150 something. Then again, you will do another one simulation. Again, you will find one CLCD that compare with the experimental one. Like that, you have to make one table, and only the CFD simulation result you have to match it. For 100, what is the CLCD? For 150, what is the CLCD? Like that, if you match it, after certain increase in number, the CLCD value will not vary. So that value you have to take it as a optimum one. I think I already explained in that. What is it? Internal one. So I'm making one table. For example, leading edge portion, trailing edge portion. So first here I'm giving division as okay, now 200. Here 70, 70, okay, 140 I'm giving. So I will get one CLCD value for a particular angle, for example 8 degree, and Reynolds number maybe 1 in 10.6 for example. I will check CLCD. Then next step, y plus also, if you want first cell height also you can change it if you want. And next I am going for 300. Here maybe 200. I will check CLCD value. Then I will go for 400. Here maybe 300. I will check CLCD value. Like that, keep on. You have to increase at least 5 to 10. Then after certain value, the CLCD value will not vary. For example, if I increase to 500, 600, 700, if the CLCD value is not changing, then this will be my final mesh. 400, 300, y plus maybe equal to 1 or less than 1. So this will be my final mesh. Like that, you have to refine it. So what I am giving this 100, 200 and all, just for the demo purpose, I am giving the value. But if you want to exactly find the proper mesh, you have to do this analysis, mesh independency analysis. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Hello?
Yes, sir.
Ravi sir?
Yes, sir.
Good.
Yes, sir.
Ravi sir, anything to add here? Yeah, I heard.
Actually, yeah.
Ravi sir?
Yes, sir. Can you hear me? Sir, can you hear me?
Yes sir, yes sir.
Yeah.
Yes.
Actually, there are certain things that you'll be facing error during the creating the blocking and all those things. I will explain the stuff later when you come to the university, or else I'll try to share a video based upon that, how to rectify those things. Sometimes when you create a split phases and all those things, it will create a two phases on the same region, so which create overlapping phases and it will create an overlapping mesh. So sometimes it happens based upon what techniques that you're using to create a split. So if if the cutting edge is not proper and all those things, it will lead to form two overlapping phases. So sometimes you're not able to find out that, it will not show you an error. When you import it and do the meshing only, you'll be able to realize that there are two different meshes in the same region. So then only you'll be able to identify. So to avoid that kind of a scenario, there is one precautionary method is there, where once you save the IGS file of your the domain which have been built, you need to reopen that IGS file alone in the CATIA again, not the cat part, IGS file. And you need to look at the, now suppose if I say there are six phases in your domain, then you need to have only 6 phases in the tree. You have the main tree, right? In that main tree, you should have only 6 phases. If you have more than 6 phases means, then some more extra phases is there in that particular thing. So you need to click on each and every phases, find out where is the location it is getting highlighted in that particular domain, and see which two phases is highlighting the same area. So after that, once you identify that, you need to remove any one of the phases. After that, you need to save it and you need to use. So that will rectify the problem. So this is just a ensuring method that you don't have any overlapping phases. So in the case where Sarah has done it, it will just a normal procedure which you need to follow. In order to ensure the checking, you need to do this extra step. That is one thing that I need to add up. Other things, Sarah, I think Sarah has explained. Yes, sir. That's it.
Okay. 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 So what Sir is telling, so here I have drawn the rectangle separately. I have drawn one rectangle here and another rectangle here. Okay. So and I splitting, right? So there is no issue. Sometime, so you may draw the rectangle first here. Okay. If it is external, it is okay. Or it has to be coincide properly with this existing profile. Instead of coincide, if you draw the profile like this, then this portion will create it as a separate one. Similarly, if you are drawing another one profile here and doing the splitting, these two lines also should be coincide properly. If you don't coincide, there may be a small gap. Okay, this will create as a separate phase. Like that, this issue will come. Sir is telling sometime there will be two phases overlapping here. So these type of issues, some people will get it if you try some other methods. So there is a way to check it. After IGS file, again you input it. There you can see number of phases. Whatever 5 phases mean, there also it will show 5 phases. If it is exceeding or less than that, then you have to ensure where it goes wrong. That's what Sir is telling.
And one more thing.
The method I followed now, it won't create a type of.
Yes, just sorry. Just I want to add up. See, the meshing isn't just a kind of an art which is not dependent on one particular problem. And whatever Sir says is just one of a kind which can be used. There are various ways to go, and different people will do different types of meshing. Okay. So Sir has given you one simplest way of doing how to do the mesh for a given airfoil. Once you get an understanding, you can also create more detailed mesh as much as possible, more blockings based upon what you're trying to determine. If you know what is the region that you're going into. Now you have 0-degree angle of attack, but if you're going for higher angle of attacks, then the meshing can be little changed in order to get a proper thing. So mesh is not something that is going to be standard for all the problems. It is going to differ based upon how you're approaching the problem. So that is very versatile, and it's like an art that you need to look under. So yeah. Yes, sir.
Yeah, thank you, sir. Correct. So, Sir said you should know where to refine. Okay, that and all depends upon the problem only you can identify. For example, here it is 0-degree. I know the wake region will be behind it. So, I am going to refine this region. Depends upon the object, depends upon the flow condition. You should refine the particular flow region where you are interested to find the properties. Okay, so here I refine only the leading portion of the aerofoil. Now I will come to this trailing edge portion. So in the trailing edge, here also you can use the bias. You can create refined meshes in the trailing edge, or you can give refinement on both sides. That is here on refinement, here on refinement. In the center, it can be medium size. Anything you can try. 1 minute. Okay. So here I am going to try the simplest method. That is, I am going to use the uniform mesh distribution here. Later you try bias, maybe refine towards the trailing edge or refine towards both sides. It's up to you. Again, go to insert sizing. As I am going to use uniform method, at a time I can select both the edges. I selected both the edges, apply, and number of divisions. Okay, approximately I am taking 70. There is no bias. Simply update. Okay, now see how the meshes are generated, and you have to ensure there should be a smooth transition. See here it is very fine, then it is increasing. Okay, and you couldn't differentiate the two different meshes, right? Like that, you should give the smooth transition. Suddenly, for example, here if you refine it, you may get the very fine meshes here. In that case, it will be fine, coarse, then again fine. Like that, there will be discontinuity. So there should not be a discontinuity. Sorry. So if you see, there should be a smooth mesh transition. So according to that, you have to decide the 170 and all. So already I tried. So with the 170, I'm getting the smooth transition. So I'm explaining to you. And here also in the trailing edge, up to this it is small and suddenly it is increasing. Here also I can a little bit decrease the size so that here also the transition will be smooth. Okay, so here I am giving only division. There is no bias. If you want, you can give the bias. It's up to you. Now you can go for the remaining edges. So which one I can give? Okay, this one I see. I will select it. All these horizontal lines, 3 lines I selected. Number of divisions I'm trying 70, and I'm going to give bias factor because here it is very coarse. I have to refine it here near the aerofoil. So first I'm selecting the first option, bias factor 70. This also you should change it. You can try with first 20, 30, 40, 50 and all. I tried with the 50. It comes properly. So everything is trial and error. And select. Now you can see the refinement. But at a time I selected the 3 edges. So these two it follows properly, fine and coarse. But the last one it changed. So I should. So remove this. So simply select and this minus sign. So only these two line I am keeping in now. Then update. Okay, these two it is refined. Now this line I have to do it. Mesh, right click, sizing, this edge. Number of division is 70. And bias factor. This time I think I have to select the second one. Bias factor is 50. So it is fine, and here it is coarse. Update. Now you see the vertical lines. It is refined here and coarse towards the outer line. Here also it is somewhat uniform, right? See, it is the cell size is increasing, and this there is no much difference. If you want further, you can reduce to the bias factor 52, 52, 55, like that. You have to do the trial and error. But I feel this transition is good only. There is no much difference between these two cells. So I am stopping here. So vertical horizontal line I defined. Now I have to define these vertical lines. I have 6 vertical lines. 1, 2, 3, 4, 5, 6. Again, go to mesh, insert, sizing. Again, at a time I need to select all the vertical lines. Let's see which are all following the same behavior. At a time I selected. And here I'm selecting some 60 divisions. And bias factor, I need refinement near the airfoil. So first select the first option, bias factor. Okay, here instead of bias factor, I'm going to introduce another one term. So instead of bias factor, there is a transition with a growth rate. Growth rate means it shows the it's a ratio of second cell and the first cell. Bias factor means it is a ratio of size of last cell to the first cell, and this one growth rate ratio of second cell size to the first cell size. So at every cell there will be a 1.2 times growth. For example, first cell may be 1.2 meter, for example. Then second cell it will be 2.4 meter. Like that, there will be a growth rate. The same growth rate it will follow. Okay, I'm giving initially 1.2 and check these two line. It is refined near the airfoil, but this also refined. But these three line it is showing the opposite behavior. So I have to remove this line. Just select minus, select minus, select minus. So these three lines we have to give it separately. At a time we can club only these three vertical lines. So in the Y plus calculator, simply if you type Y plus calculator, you will get n number of options. So better select the first one. This calculation already I showed to you. So here you have to define the velocity. Mostly in the wind tunnel we are taking 20 meters per second, and I am going to take chord length is 1 meter and Y plus value. So for the proper boundary layer prediction, we need Y plus value less than or equal to 1. So I'm keeping 1 now. Then calculate. With that I am getting my first cell height should be 0.00002 approximately. Okay, so this I have to ensure while creating the mesh. So first you have to try with 1.2, but actually I tried for 1.15. I'm almost getting the same height. Let's see, I'm giving 1.15 now. Then update. The bottom it is updating. Some noise is coming. You can mute it. It takes time. Okay, it's update. No, still it is updating. Okay, so only one side I updated. You can see the refinement towards the airfoil. Now I have to give for the remaining line also. Don't get confused why it converted into unstructured. If you give properly for the upper line, this also will get changed. Okay, now we'll try for the upper lines. Sizing. Now I'm going to select these three vertical lines. Control and select. And number of divisions given 60, I think. Then instead of first one I am using, and instead of bias factor I am going to use premium. So you see it is refined now towards the airfoil and towards the outer line. Now I can update. Same condition. I'm giving separately for upper lines and lower lines. Now again update it. Now you will get the proper structured mesh. Created. And here some error, they have rectified it. It's okay. I'll rectify it. So now it is refined near the aerofoil, you can see. And as I said, that first cell height, right, that you can verify here itself. So everywhere, so it is uniform because of structured mesh. So this is the first cell height, right? I'm zooming it. See the bottom one, you can see the scale. This black and white scale. It shows 4 into 10 power minus 5. But in the calculation, I got it point, that is 2 into 10 power minus 5. But here I have 4 into 10 power minus 5. So this I can take it as a first case. I can check the CLCD. Then the next time when I refining it further, that time I can refine it further. Instead of 1.15, I can give 1.13 maybe. Like that, you have to change it. Is that clear?